semantic feature is and how to use this model. Now, I will give my description. Semantic feature is one character of the concept. Let's see one example here. Every sentence in English must have subjective, predictive, and objective, these three parts. So we can simplify nearly every sentence in the English expression with this tuple. This tuple has three parts. The first one is subject, the second one is predict, and the third one is object. So with the predict plus object, we can use these two to describe one subject. So you can see here, the predict plus object is the semantic feature of the subject of the whole concept. In this case, the main idea here is to find the semantic feature of different words and calculate the similarity matrix. So how does it mean? It means that, for example, for one plain text, you divide each sentences, and then you make a simplification of each sentence as the tuple here. After that, you go through from the first entry in the tuple to the last entry in the tuple, and record how many different semantic features are. And then for each concept, you can see that how many features in the total features to describe this concept. You recall that number. Use that number to divide the total semantic feature number. You will get the word similarity. If from my description you may see that this will be a little difficult. Now I'll give you one example. This is the semantic feature I get from the case study 1. It has, here you can see that it has 5 features. The first one has water, and the second one is animal. The third one is mammal. The fourth one is live water, and the fifth one has fur. There are about 5 concepts here. One is mammal, the other one is cat, then fish, whale, bear. For the mammal, you can see from the text that there are 2 semantic features for them. So use 2 divided by 5, you can get 0.4 similarity. For cat, fish, whale, and bear, you can calculate each separately and then get the similarity list on the right here. From this example, you can see that we can easily to calculate the similarity list of each concept in the plain text. So the next question to use semantic feature model is, how can we construct the topology of the whole plain text based on the similarity matrix? So this is our method. The whole method includes 4 procedures. Firstly, you should scan the similarity list and perform the sort operation. How to sort based on the similarity value. If you get the biggest value with you will perform the sort as increase or decrease. This is the first procedure. The second one is calculate the average similarity difference and use this difference to divide the similarity list into several groups from the root node. Let's see from here. What is the similarity difference? After you sorting the whole similarity list, you can get the similarity difference between the adjacent concept. For example, mammal and cat, the similarity difference is 0. Cat and fish is 0. Fish and whale is also 0, but whale and bear, the similarity difference is 0.2. Based on these 4 numbers, you can get the average difference as 0.5. It means that 0.2 divided by 4. So you can get that number. Based on that number, you can divide the whole similarity list into several groups. Here, you can see that you can divide the whole list into 4 groups. Mammal, cat, no, for two groups. Mammal, cat, fish, and whale are the first group. Bear is the second group. After these two procedures, you can build a topology. The method cite the largest similarity concept as the root nodes and the following groups at each level of the tree, then construct the relation between the adjacent level nodes on its feature. What does it mean? It means that from the biggest similarity value to the smallest one, you cite the biggest one as the root node. There's one question here. Maybe you will get many words with the biggest similarity value. You can see here. This is one example. You have 4 concepts with 0.4, the largest similarity value. So in this case, these 4 nodes will also be set as the root level. So here, the root not only mean one node, it can be many nodes. Then you cite the second group as the next level, then the next level. After you build this kind of thing, you can build the relations between each level. How to build that? The method is that you go from the second level of the tree and see whether the word in this level has the relation with the that level. What's the relation mean? It means that whether it has the semantic feature in this level, then in that level. If it has the semantic feature, then it means that the node in a level n will has the relations with node in level n plus 1. If not, there will be no relations. So this is the method to build the topology. Let's see. The following part is the topology I get for the case study with semantic feature match model. You can see that there are 4 words in the root level and there are 1 word in the second level. Why there is no relations between them? Because from the plain text we can see that mammal and bear has no semantic feature. Cat, bear also has no semantic feature. Which fish and bear has no semantic feature, and whale and bear has no semantic feature. So, based on this point, I mean here, there is no relations between the concept here. So the whole thing is about the semantic feature model. The next one is the relation associative model. This model will also use the tuple in the previous section. As each sentence can be simplified by the subject, predicate, objective, so you can build the relation between subject and object as below. So here, in this table, you can see that mammal and vertebrate has relation: mammal, animal, cat, mammal, fish, animal, fish, water, whale, mammal, whale, water, cat, fur, and bear, fur. So there are about 9 relations for the case study 1. Based on these relations, I use the diagram construction method to build the topology. What is the diagram mean? It is one kind of the network. It includes the vertex and edges. The graph is directed, and there is no loop in this kind of graph. The diagram construction method is widely used in the computer science area. For example, in the compiler theory, compiler area, people also use the diagram construction method for code optimization. Here, I modified the graph construction method here. Because there are many possibilities that in the plain text, 2 words can get relations with each other. For example, I have a computer, and the computer can be programmed by me. In this example, computer and I have relations with each other. So here, in my modified diagram construction method, there can be loop in here. So the method to build the polar